Okay, good morning. What was the last thing we did the last time we met? Last 2 weeks? Who remembers the last thing we did? Anybody can respond.
So please, it was on perimeters, areas,
Okay.
and volumes.
Yeah, I just wanted to be sure. Okay, thank you. So let's then move to our next topic. Right, so for these ones, we move to my system is a bit slow. Okay, so we are right. We finished with this. So our new topic today, which is our unit 3, is about equations and inequalities. Equations and inequalities. So we'll be doing it for some time. If we are not able to finish today, we'll continue on next week, God willing. So equations and inequalities. And these are the subtopics under equations and inequalities. So we want to treat simple linear equations followed by simultaneous equations. And then after simultaneous equations, we do quadratic equations. We look at some graphical solutions to equations. We look at variations, and then we have inequality functions. So we'll move step by step through them, and then as usual, at a point, I'll pause for you to ask your questions. Right. So let's start with the simple linear equations, or the word equation. We want to understand it when they say you have an equation. So equation is always formed when you write an expression with an equal sign in it. So for instance, if I write m plus 2, and I bring an equal sign like this, and I write 6. Because of this equal sign, the above expression is called an equation, because the mathematical expression you have written here, all you are trying to tell everybody is that the left-hand side conditions are the same as the right-hand side conditions. That is what you are saying, that the left-hand side condition is equal to the right-hand side condition. That is an equation. But if you remember what I just said about the topic, I said for some time we'll be treating equations and inequalities. They are two different things. For equations, you always see the mathematical symbol of equal sign in between the left-hand side expression and the right-hand side expressions. But inequalities are different. Inequalities, there are about 4 signs you can see. You can either see less than, in between the left-hand side and the right-hand side. That's one condition. Or you may see the symbol greater than, in between the left-hand side and the right-hand side. Or you may see the symbol greater than or equal to between the left-hand side and the right-hand side. Or you may see the symbol less than or equal to in between the left-hand side and the right-hand side. So you see that for the inequalities, there are several options. Unlike the equation that you only see an equal sign, the inequalities, you have 4 different signs you can see. So let's start gradually with the equation. Now that you understand the basics of an equation, let's see how equations are formed. So equations are formed using something we know already called algebraic expressions. Algebraic expressions. If you remember my definition for algebraic expressions, it's a combination of alphabets and numbers. Alphabets and numbers are used in forming algebraic expressions. So most equations are formed with algebraic expressions. And so if you see an expression like this, negative y plus 5, this is not an equation. It is an algebraic expression. If you see 10k standing alone, this is also not an equation. It is an algebraic expression. If you also see the fractional one, a divided by negative 7b squared c5, this is also not an equation. It is an algebraic expression. Okay, so what makes the equation, what changes the algebraic equation, what changes the algebraic expressions into the equations are the equal signs. The equal signs change them to become equations. So this is a proper equation. 3x minus 13 equals 29. It's a proper equation because of the presence of this equal sign. That makes it an equation. And then 2 plus y equals negative 11. Even though it is an algebraic expression, because it has an equal sign, it becomes an equation. 3m equals 4m minus 2. Because of this equal sign, it means we have an algebraic expression which is forming an equation. So the simple way you can define an equation is that an equation is an entity that always contains an equal sign. That always contains an equal sign. So that is an equation. Okay. Right. So if that is an equation, then let's see how equations appear, how they appear, and how they are formed. And we want to start with the simple equations that you see every day. It is called the simple linear equation. once you see the word linear as an adjective qualifying the equation, linear is coming from the word line. Okay. So it means that you can use lines to form an equation. And simple linear equations are formed by lines. Okay. They are formed by lines. This particular type, there are 3 types in appearance. There are 3 types in appearance, and we want to take our time and look at them one after the other. So the first type is called the standard form linear equation. The standard form linear equation. How does it appear? This is what we are discussing. It's saying that you have a certain ax plus by equals c. Now the a, the b, and the c that are written in uppercase form, they will actually be numbers. They will always be numbers. Okay. And then the lowercase x and y will always be alphabets. That is how those equations look like. So let's pick an example for you to understand what I'm saying. Now look at this equation. 3x plus 4y equals 5 is a standard form equation. Why? Because you have a number and an alphabet plus another number plus an alphabet equals a number, like the way it has been written up here. A is supposed to be a number, B is supposed to be a number, C is supposed to be a number. So anytime you see an equation written in this form, 3x plus 4y equals 5, it is a standard form simple linear equation. Long name, standard form simple linear equation. So that's our first one now. 3x, anytime you have a number multiplied by a variable plus another number multiplied by another variable is equal to a number. We call this one standard form simple linear equation. Standard form simple linear equation. So that is our first example. The second example can be any number. So let's take another example. I can write 4k plus 2w is equal to 7. It's the same thing. Standard form simple linear equations. Why? Because you have a number times a certain variable plus another number times a certain variable is equal to 7. Why is it standard form? Standard form because both variables, x and y, are at the same side, or they are on the same side, the left-hand side. They are all on the left-hand side. So when all the variables are on the left-hand side, we say it is called standard for simple linear equation. If all the variables are on the same side. Now, what if the variables are not on the same side? If all the variables are not on the same side, then we are going to have a different name. And that name is called the slope form intercept. The slope form intercept. That is when the variables are not on the same side. Not on the same side. And the variables are not on the same side. So this is also the general equation. The general equation for the second type is y equals mx plus c. Let's compare it with the first one. Here, the x and the y were on the same side. But this one, y is on the left-hand side, and then x is on the right-hand side. The m you are seeing here, the c you are seeing here, will always be numbers. They will always be numbers. Just as this A and B and C are numbers, the M lowercase, the C lowercase you are seeing here are always numbers. Okay, let's look at an example here. Now look at an example. Y is equal to 3x plus 5. Y is equal to 3x plus 5. In this case, the M is the 3 you are seeing here. The C is the 5 you are seeing here. X is on the right-hand side. Y is on the left-hand side. Another example. Y is equal to 5 plus 6x. Y is equal to 5 plus 6x. It's the same thing. They have just changed the position of C and M. So the 5 is your C. The 6 is your M. Y is on a different side. X is on a different side. So that makes it the slope intercept 4. The slope intercept 4. That is how to write an equation like that. The slope intercept 4. So the full name of this equation is slope intercept form simple linear equation, just like we combine the first one. So if we pick an example that we showed, any equation that is like this, y equals 3x plus 5. Because x is on a different side and y is also on a different side, it is called the slope intercept form of a simple linear equation. So that's a long name. That's the second type of simple linear equation. And then finally, the third type. We want to look at the third type and see the features, how it looks like. So the third type too is written of the form y minus y1 equals m into x minus x1. So this one, you are seeing the y appear twice, but just that whilst one is y standing alone, the other is y with a 1 below. The one here means first point. The one you are seeing here means first point of y. First point of y is equal to m into x minus x1. So just like the y, the x is also appearing twice, but the second x has 1 as a subscript. And that 1 is also referring to the first point of x. So whilst y1 is the first point of y, x1 is the first point of x. And anytime you have an equation which has an arrangement like this, we call that simple linear equation as the point slope form. Point slope form. Point slope form. Because you are starting from a point and you are starting from the first point of y, which is y1, and then the first point of x, which is also x1. And this is an example. Y minus 5 is equal to 2 over 3 into bracket x plus 2, bracket close. And the meaning is that the y you are seeing, this y is the y you are seeing here. Okay. Then this number that is appearing after the y is your y1. That is the first point of y. It's equal to 2 over 3. 2 over 3 is the m you are seeing here. And then the bracket opens. This x is this x you are seeing here. And then this x1, which is the first point of x, is the 2 you are seeing here. And that is how the point slope form is written. And so if we are also to give it a long name like the others, this is how we are going to name it. So if you have an equation of this form, y minus, let's say 2 over 3 is equal to 1 over 7 into bracket x minus 4. The moment you see this, the point slope form should come into your mind because this is y, and any number that follows it is the first point of y. So this one becomes your y1. It's equal to, and then a certain number before the bracket will always be your m into bracket x minus the next number that follows will be your first point of x, which we call the x1. Okay, so any simple linear equation written of this form is called the point slope form, simple linear equation. Point slope for simple linear equation. So these are the three features of the simple linear equation. They are different in form, but they are all simple linear equation. And I want you to look at them one more time and compare with what I've said, that in simple linear equation, you can either have a standard form or you can have a slope intercept form, or you can have a point slope form. What are the differences? The differences are that for the first one, both x and y are on the same side of the equation. They are on the same side of the equation. What about the second one, slope intercept form? It also means that you will see that the x and the y are not on the same side. They are not on the same side. So that is the difference between the first one and the second one. And then the third one, also, you still see that both x and y are not on the same side. That's the first thing you see. And then secondly, they have their starting point with them. They have their starting point with them. And the starting points are what we pointed out. Y1 is the starting point for y. And then x1 is the starting point for x. And these are the three forms of equation you can always see when you are looking for simple linear equation. At this point, let me open the floor for questions before I try doing examples. Any questions so far from what we have done before I proceed? Any question about the standard form, slope intercept form, and the point slope form of simple linear equation? Yes, Abraham, unmute yourself and ask your question.
All right. Good morning, sir.
Good morning.
Yes. So with the third example, that is point slope form. Let's say y minus y1 equals m into bracket x minus x1. So the example you gave under it, y minus 5 equals 2/3 into bracket x plus 2. Why is it the plus 2 is not minus 2?
Oh, no. As for the signs, that will change.
Okay.
It can be minus or plus. This can be plus or
Okay.
it can be minus. Yes, so that's a good question. The signs can change. Even here, the same thing. Here, it can be minus. It's always not plus. Here too, the same. It can be minus. So the signs can change. It will be either minus or plus.
Okay. Thank you.
Yeah, that's a good question. Any other question? Okay, so let's proceed after Abraham's question and see what we can do again. Now, we also want to, we are still on the first simple linear equation. we want to now look at various equations we can come across. Now, simple linear equation, like I told you, is coming from a line. Why? Because when you have your usual plotting you were taught some time ago, they will tell you plot y-axis, plot x-axis. So you have y, you have x, and then you have a line. So the line, they will tell you find a slope and then get an intercept. Okay. So you see that you are always seeing y, you are always seeing x. You come across m, you come across c. So that was why we had the formula y equals mx plus c for the slope intercept form. It's all coming from this line. In this same line, you can have two starting points. Starting point 1, starting point 2. So starting point 1 means you have x1. Starting point 1 means you have y1, like this. So if you want to introduce y1 and x1 into this one, very simple. That's the last one you saw. Y minus its starting point is equal to m into x minus its starting point. And this was the equation that gave you the point slope 4. Okay. So all this, we are seeing x standing alone. So it means that for every line, when any letter is standing alone, I told you the other time that it's the same as x raised to the power 1. Any number raised to the power 1 is the same as the number or alphabet. 2 raised to the power 1 is the same as 2. 1,000 raised to the power 1 is the same as 1,000. Therefore, x raised to the power 1 is the same as x. So for simple linear equation, we say that the greatest power on the variable is 1. Like you are seeing here, 5x plus 10 equals to 13. When you are asked, what is the power of x? It is 1, like this. It is 1, even though we don't write it, but it is 1. So that any number raised to the power 1 will give you the same number. So that is one way of identifying linear equation. For linear equation, make sure that all the variable you are seeing is raised to the power 1. And then you can get your line equation or linear equation. But it is always not like that. Sometimes the variable will be raised to the power more than 1. And let's see what happens here. Look at the first equation. 8x plus 3 is equal to -9. This x here is having the power 1. So because of that, it is like a line. So it is a linear equation. But look at the x here. It's raised to the power 3. Once it's raised to the power 3, it cannot be a line, because for every line, the variable should be raised to the power 1. And so once this is not 1 and it is more than 1, we call it non-linear because it cannot come from a line. Any equation that cannot come from a line is called a non-linear equation. Look at this one too, 7 over x. 7 over x, this x, if you are bringing it, it's raised to the power 1 like this. But when you are bringing it up, it will become x raised to the power -1. And because it is not x raised to the power 1, it is also called non-linear because we are seeing a negative number there. For linear, there shouldn't be any negative number. It should be just 1. And then look at the last one, square root of x minus 4. This square root, you can rewrite it as x minus 4 raised to the power half. So x raised to the power half is not a line. So this is also non-linear. In other words, there are 2 types of equations. There are 2 types of equations. The first one is what we have started doing today. The first type is called the linear equation, where always x or any variable is raised to the power 1 and not any other number. And then the second type is that when x is not raised to the power 1, it is called non-linear equation. It means that the power of x is either less than 1 or more than 1. Less than 1 or more than 1. It makes it non-linear equation. Right? So let's see how we can generate the equations that we have learned today. And as a recap, let me write them somewhere so you can follow through. The first type, which we wrote today, which we call the simple form. The simple form, we wrote it as ax plus by is equal to c. So this one was the simple form we wrote today. Those of you have just forgotten, I'm talking about the standard form, this one. Ax plus by is equal to c. The standard form. So standard form. Then the second one we wrote today, which was y is equal to mx plus c, which we also name as slope intercept form. Slope intercept form. And then the third one we wrote today, we said y minus y1 is equal to m into x minus x1 which we named as point slope. For point slope 4. What I want to add to this before we start solving the exercises is that if you remember, at the lower levels, those of you who can remember, when you were plotting y against x, when you get a straight line, they will tell you will find the slope m, and you were taught that the slope m is change in y, change in y divided by change in x. Let's see why you were taught this. Change in y divided by change in x. Look at this one. This point is where the x is starting. So this is x1. This point is where the x will end. It's called x2. When you come to the y, this point is where the y is starting. So you have y1. And then this point is where the y will end. And so it becomes y2. So when they say change, change means subtract the smaller one from the bigger one. So the m formula finally becomes y1 and y2. y1 is the smaller one. So you have y2 minus y1 divided by this one to x2 will be bigger. x2 minus x1. So this becomes a formula we will use to find m when we don't have m in the question. Okay. This m you are seeing here, sometimes it is not given in the question. You have to use this formula to find it. The same thing here. The m you are seeing here, sometimes it's not given. So this is the formula you use to find the m. Change in y over change in x. Change in y over change in x. So let's use this idea to solve the exercises we have been given. Let's go and check first of all that which of these three.
Please, a quick one. I want to have some clarification here. The standard form, the ax plus by equal to c. So, meaning that that form is not always going to be, you are not always going to have the x and the y on one side to have it as standard form, linear. But then you can also have only one variable there and it still be a linear standard form. That's the clarification I want to get. Because
No. When all of them are on the same side, it's called the standard form linear equation.
okay.
But when they are not on the same side, like the point number 2, they are not on the same side. Y is
very well,
standing there.
X okay, so okay, I get that, sir. So for example, 2x plus 5 equal to 10. So with this example, you see we don't have two variables on the one side.
I'm coming 2x plus
Plus
what?
5. 5
5.
equal to 10.
Is equal to what?
Equal to 10.
10. Okay.
Yes, yes, please. So the point I'm trying to make is that,
Mm-hmm.
meaning from this scenario, from this example, we are not always going to get two variables on one side. Because
Yes.
in this case, we have only one x. We have x, we don't have y there.
Yes. So here what it means is that y is 0.
Y is 0. Oh,
Yes.
okay.
That's
Oh,
what it
okay.
means. So when you are writing this one properly, all numbers will be on the same side. So from here, you see that we've been writing that 2x is equal to, this 5 is coming. So you have 10 minus 5.
Yes, 5.
Good. Then you have 2x is equal to 5. So at this
Okay.
point, then you compare. At this point, you compare. So I see ax here. So it means that a is 2. And this is
Okay.
the x. Now by, I'm not seeing any y here. So once I'm not seeing any y here, it means that y is 0.
Y is 0. Oh, okay.
Yes, so everything is gone. And then c, there's supposed to be only one number here, c, and then my c is the
The
5.
5. Okay.
Yes. So this one qualifies to be a standard form.
Okay.
Because
Yes.
if you want to come to point number 2, point number 2 is saying that the x should be on the right hand side with a certain number. But
Yes.
here, x is on the left hand side. Are you getting it?
Yes, sir.
Yes. So that was a good question. I want you to know the features very well when you are asked. Like the example you have given me, I can write this, that 2x plus 5 equals 10. Which type of form of linear equation is 2x plus 5 equals 10? I expect you to compare with what we have done, and then you can come out with what we have arrived at. That for this one, it is the first type, because the first type, the x is always on the left, the y is always on the left. But in our example, we are not seeing any y. Once you are not seeing y, it means that y is 0. And on the left-hand side, we are supposed to see a number represented by c, and we have 5 representing the c. Are you clear with that?
Yes, sir. Yes, I'm very clear.
Yeah, please. So if you have a question, ask like the way Anthony has asked, to clear your mind. If you are not sure of something, just clear your mind before we start the rigorous calculations, because these are the 3 forms that you are required to know, and you'll be using them as we move higher on the maths. Okay. So let's look at the exercises. Like I said, we may have to use either 1 or 2 or 3 to solve it, but we need to look at the question first. These are the exercises. Now, the first one reads this way. Write an equation. Write an equation. It didn't say solve. It didn't say solve. Write an equation for the line that passes through the points 3, 4, and -1, 6. 2. Write an equation for the line that passes through the points -2, 5, and 1, 7. So in the writing of the equation, we may have to come out with one of these. Either our equation should end up becoming a standard form linear equation, or a slope intercept form equation, or a point slope form equation. It has to be one of them. Now let's look at how we can proceed with the information we have. So for the information we have, we've been given 2 points. Let's label them and be sure of what we are doing. write an equation. Write an equation for the line that passes through the points. So the first point, 3, 4, means that x1, the first point of x, which is called x1, is 3. Then the first point of y, which is 4, is also called y1. And then when you come here, another point. So this is a second point. So second point of x is x2. Anytime you see two coordinates, the first point is the x, the second is the y. And then 6 will be the second point, y2. Okay, for that. So it means that for this equation, we have 2 points for x, which are x1 and x2, and the 2 points for y, which are y1 and y2. So let's decide which form we want to put it, either the first form or the second form or the third form. The information we have been given, if you cast your mind back to how to find m, these are the formula that is used for m. Remember, for the first one, which is the standard form, you don't need m. There's no m in the equation. Okay, there's no m in the equation. But for the second form and the third form, I'm seeing m in the equation. So it means that we can do something with this m we are seeing here. y2 minus y1 over x2 minus x1. Exactly, we've been given what we need. y2, y1, x2, x1. So we can quickly find our m. So in finding the m, we'll have m equals y2 minus y1 divided by x2 minus x1. So let's pick the numbers now. y2 is 6 minus y1 is 4 divided by x2 is negative 1 minus x1 is 3. So when we put this together, we have 2 divided by negative 4. 2 divided by negative 4 will give you negative 1 over 2. So we can say that the m for this first one is negative 1 over 2. Let's see how we can use it to write our equation. Let me clear the stuff here now. And then let's see how we can use the m we have to write an equation. And even which of the equations can we pick to make life easier for us. Right. So let me put them together now. Let me write them as it is here. And then we can use it to work. From the question, these are 2 points. 3, 4. First point. Second point. Negative 1, 6. The m we had, the m we just had, we had negative 1 over 2. And now I did mention that this point we have, this 3 is our x1. This 4 is our y1. This negative 1 is our x2. This positive 6 is our y2. So with this information, x1, y1, x2, y2, m negative half. Which of the equations do you think will be easier to pick? When I check through the three, I see y1, I see x1, I see m, and I have those information here. So once I have the information here, I would like to use the point slope form because it becomes easier. This y, of course, will still stay. So I have y. Then according to the formula, minus y1. What is the y1 in the question? The y1 is 4. I have 4 here. Is equal to m. M, we have found it. We had m to be negative 1 over 2. So negative 1 on 2 into brackets. Then I see x. So this is the x minus x1. X1 is in the question. That is 3. Okay. So simple. Once I fix everything into it, I have formed the equation. And this equation is of the form, the point slope form. If the question says that, okay, no problem, now change your answer to the slope intercept form, what do you do? Because there can be a follow-up question like that, that after getting your point slope form, change the equation to the slope intercept form, meaning work around to make sure that y is standing on the left-hand side alone, and then x is also standing on the right-hand side alone with m and c. So let's see how we change this one. So the first thing you do is that we need to get rid of these two, because if you look at the slope intercept form, there is no number dividing. No number is dividing here. So these two will have to clear. So what do? We have to multiply through by 2. It means that everywhere should be multiplied through by 2. So when we take this one, we'll have 2 times y minus 4 is equal to 2 times negative 1 over 2 into x minus 3. So then we do our cancellation. This 2 will cancel this 2. And then we can proceed. So we have 2 multiplied by y, we have 2y. 2 multiplied by negative 4, we have negative 8 is equal to x minus 3. So we have x. There's a negative sign here. So negative 1 times x, we have negative x. Negative 1 times negative 3, we have positive 3. Then this will also go. So we have 2y is equal to negative x plus 3. This negative 8 is coming, so it becomes positive 8. We have 2y equals negative x plus 11. The point slope form, the y is standing alone. There's no number. The y is standing alone. So it means that for this y to stand alone, we need to divide every side by 2, every side by 2, every side by 2. Therefore, finally, this 2 will cancel this 2, and then we have y is equal to negative x over 2 plus 11 over 2, finally. So it means that the same equation, we have changed it to the slope intercept form. The slope intercept form. It was in this form, point intercept or point slope form. And we have changed it to slope intercept form. Again, you can be asked to change it to standard form. How do you change this one also to standard form? Where standard form says that both x and y will have to be at the same side. This is the easiest of all. You just transfer this negative x over 2 and bring it to join the y here. So finally, you have that one as y, negative x over 2 crosses, and you have plus x over 2 is equal to 11 over 2. Now, if you look at this one also, there is no division sign here. So it means that we have to get rid of these two. So in getting rid of these two, it means that, again, like we did here, multiply through by 2. So that's what we do here. So look at solving this side. Multiply this one by 2, you have 2 multiplied by y plus this one 2 multiplied by x over 2 is equal to 2 multiplied by 11 over 2. And then you do your cancellations. This 2 will cancel this 2. This 2 will cancel this 2. So you have finally 2y plus x is equal to 11. And this is your final answer. 2y plus x is equal to 11. And this is the standard form. So, ladies and gentlemen, we've been able to write the equation in all the three forms. The same question, if you want to leave your answer in standard form, this is how it will appear. Both y and x are on the same side. And then c, which is a certain number, is on the right-hand side. If you want to leave your answer in the slope-intercept form, y should be standing alone at the left-hand side, and all the others will go on the right-hand side. If you want to leave your answer in the point slope form, it means that just as we entered, you have y with its starting point 4. You have x with its starting point 3. And this becomes your answer. So I can ask you this simple question that write an equation in 3 forms, being the standard form, the slope-intercept form, the point slope form, using the points 3, 4, and -1, 6. very simple question, but the solution can be plenty because you need to change from one form to the other. Any question before I try solving the second one? Any question about this solution? The first form, the second form, and the final form. Any question about these three solutions? Okay. So your silence means you understand what we have done. So we are going to use the same approach. We use the same approach to solve the second one. And I'm sure by the end of the second one, you will be clearer in your mind as to how to solve simple linear equation in the three forms we have learned today, which I keep repeating: the standard form, the slope-intercept form, and then the point-slope form. Okay, so let me prepare the space for the second one. And then again, I'll give you the opportunity to ask any question to clear your mind in terms of the three forms: standard forms, slope-intercept form, and then the point-slope form. Okay, so let's same thing. The second question too, we've been given 2 points. So we use the same 2 points like we did for the first one to get our M, and then we can proceed with the other solution. So there's the second one. Write an equation for the line that passes through the points -2, 5, and then 1, 7. So the first thing you identify is your first number, is your x1. Then the second here is your y1. So these are the starting points. So these are the start, we call them the starting points. Starting points. Then we come to the second set. This is your x2. This is your y2. And these are the ending points. So now that we have the starting point and the ending point, it will help us to find M, because M, the formula I wrote was the ending point of Y minus the starting point of Y divided by the ending point of X minus the starting point of X. This was the formula. So quickly, you look through your question and then you pick them. Y2 is 7 minus Y1 is 5 divided by X2 is 1 minus X1 is, then this is where you need to be careful. X1 is -2. So -2. So you have two negatives, negative, negative. When they come together, join, it gives you positive. So finally, we have M to be 7 minus 5 is 2. 1 plus 2 is 3. Meaning that the M we would need for this question is 2 divided by 3. So with this information, let's rewrite them and then proceed with finding the various equations. So it means for our 2 points, we have -2 and 5. The second point, we have 1 and 7. The m we found, we had 2 divided by 3. So we can now confidently say that this is our x1, starting point of x. This is our y1, starting point of y. This is our x2, ending point of x. This is our y2, ending point of y. So the easiest one to start with is the point slope for point slope for. Let's proceed with the point slope form. The general formula we have learned today is that pick the y-axis, subtract the starting point of y from it, equals, write your m, open a bracket, pick your x-axis, subtract the starting point of x from it, and then proceed. So with this one, we have the numbers already. We do our substitution. So we have y minus y1 in our question is 5 is equal to m we calculated to be 2 divided by 3. Open your bracket. X is representing your x-axis. The starting point of x, which is x1, in our question was -2. So we have -2 like this. And I said when two negatives meet, they become positive. So this is the easiest. At the end of the day, this is our final answer for the point slope 4. This is our final answer for the point slope 4. Now, what about the others, which is the slope intercept? So the slope intercept we have learned today is written as follows: that y is equal to mx plus c. It means that y and x cannot be at the same point. We have to be able to transfer them. And apart from that too, the equation will have to be on a straight line like this. So we are going to transform what we have here to make sure that we can work around this so that y can stand alone here. And so in picking this one, this is what we can do. This 3 will worry us. We need to find a way of clearing this 3. And the only way we can clear this 3 is by multiplying both sides by 3. So that's our first condition we write, that multiply both sides by the number 3. Multiply both sides by 3. So let's work around it. So we pick this one, we multiply this one by, so 3 multiplied by y minus 5 is equal to 3 multiplied by 2 over 3 into x plus 2. So we do some cancellation. This 3 here will cancel this 3 here. So finally, we have 3 times y, we have 3y minus 3 times 5, we have 15 is equal to 2 multiplied by x, you have 2x plus 2 multiplied by 2, you have 4. Now, our mission is to get the slope intercept form where y should be standing alone and all other things are sent to the right-hand side. So it means that this negative 15 cannot be here because we want y to stand alone here. So we have to move it to join this one. So we have 3y is equal to 2x plus 4. This is negative 15. The moment it crosses, it becomes positive 15. So 3y now is equal to 2x plus 4 plus 15, you have 19. Okay. We'll still look at the slope-intercept form. Y is supposed to stand alone. There shouldn't be any number attached. And so this 3 will have to go. For this 3 to go, we divide every side by 3, every side by 3, every side by 3. And then we do some cancellation. So this 3 will cancel this 3. Therefore, we have y is equal to 2x divided by 3 plus 19 divided by 3. And that becomes our final answer for the slope intercept form. Y is now standing alone. So we can say that this is the slope intercept form. The same equation in which for the point slope is y minus 5 equals 2 over 3 into x plus 2. We can still rewrite it as y equals 2x over 3 plus 19 over 3. Now, the final way we want to write this one is the first form, which is the standard form. And the standard form, if you remember the formula, the standard form, both x and y are supposed to be on the same side. And we wrote it as ax plus by is equal to c. So it means that x and y will have to be on the same side. And they have to be in the form of a straight line. So it means that we are going to also work on this one again to get the standard form. So we have to clear this 3 again. This 3 will not make it straight, so we need to clear it. And how do you do it? The same strategy, multiply through by 3. Multiply through by 3. So we pick them one after the other. We have y, so we have 3 multiplied by y is equal to 2x over 3. No, 3 multiplied by, sorry, we are multiplying through by 3. So we have 3 multiplied by 2x over 3 plus 3 multiplied by 19 over 3. Then we do the cancellation. This 3 will cancel this 3. So finally, it reduces to 3y is equal to 2x. This 3 will also cancel this 3 plus 19. From the standard form, the x and the y are supposed to be on the same side. So therefore, we can say 3y, this 2x will have to come, minus 2x is equal to 19. Three y minus 2x is equal to 19. And this is our final answer for the standard form. 3y minus 2x is equal to 19. 3y minus 2x is equal to 19. So what we have simply done today in mathematical terms is all I'm telling you, or the final conclusion is as follows. That this equation you are seeing here, let me make it bigger. This equation you are seeing here, the one I'm coloring yellow, y minus 5 is equal to 2 over 3 into brackets x plus 2. This equation you are seeing here is the same equation you are seeing here as 3y minus 2x is equal to 19. It's the same equation you are seeing here also as y is equal to 2x over 3 plus 19 over 3. They are the same, but they have been written in different forms. They have been written in different forms. And if you understand it that way, you see that when you are solving for the value of y, if you use any of them, you will get the same answer. And that is the proof I want to do with you so that you understand the statement I've made, that the slope intercept form equation, the standard form equation, and then the point slope form equation are the same. Now let's test it. Let's test what I'm saying, whether it is true that they are the same. Let's test it. And then we can be sure. Now let's try and do this. Wherever we see x, let's put 0. So put x equals 0 in all the 3 equations. And let's see the value of y we'll get. Let's put, wherever we see x, we are going to put 0. And want to see the value of y we'll have, whether we have the same y for all of them. Let's check. Let's try with this first one. This one. Wherever we see x, let's put 0. So let's write. So this is y minus 5. Y minus 5 is equal to 2 over 3. Wherever we see x, we are putting 0. So 0 plus 2. Now, when you work this one, you have y minus 5 is equal to 2 over 3 into bracket 2. So this is 2 times 2 will give you 4. So you have 4 over 3. If you want y to stand alone, it means this 5 is going here. You have 4 over 3 plus 5. When you do this one on your calculator, 4 over 3 plus 5, the final answer you get is 19 over 3. That's the answer you get. Let's do the same thing here. Wherever we see x, let's put 0 here. So we have y is equal to 2 times 0 over 3 plus 19 over 3. So we have y equals 0 times any number is 0. 0 plus 19 over 3. Finally, we have y equals 19 over 3. So look at the answer. It's the same thing we had here. 19 over 3, 19 over 3. Let's look at the last one, this one, the standard form. 3y minus 2x equals 19. Let me create space here and then do it for you to see. That is the same thing. So 3y minus 2x is equal to 19. Wherever we see x, we put 0. So we have 3y minus 2 times 0 is equal to 19. 0 times any number is 0. So we have 3y is equal to 19. We want y to stand alone. We divide every side by 3. Every side by 3. This will cancel this. Therefore, y will give us 19 over 3. So we have the same thing here. So 19 over 3, 19 over 3, 19 over 3. Meaning that all the forms of equation, when you write them very well, they will give you the same answer. When you are solving them, you will have the same answer. Any question after this example too?
Yes, sir. So, sir, please, can we also put y equal to 0 in the various equations and get same answer?
Yes. Do you want us to do it?
I wanted to see if we
Okay.
get
Let's do it. Let's do it. So let me create space, and then once we know the equations, we can just work around. So that this is the question Anthony is asking. That is a way of verification. You want to verify that all the equations are correct. If we don't get the same answers, it means that all the equations are not correct. So sometimes it is good to verify the equations you have generated. So I was doing, wherever we see x, let's put 0. Anthony is saying that let's now try wherever we see y, let's put 0 and see. So that's what we are going to do. So we are putting all the y's to be 0. So we start with the point slope form. Y minus 5 is equal to 2 over 3 x plus 2. Wherever we see y, we are putting 0. So we put 0 here. So 0 minus 5 is equal to, then this one, 2 over 3 into x plus 2. So we have negative 5 standing alone equals 2 over 3 x plus 2. This 3 is worrying us. So the only way we can clear is that we multiply through by 3. So multiply both sides by 3. So this is what we'll have. Now let me write it here for you as we proceed to get the value of it. So we have 3 multiplied by -5 is equal to 3 multiplied by 2 on 3 into x plus 2. We do some cancellation. So this 3 will cancel this 3. So we have -15 is equal to 2 into x plus 2. Then we need to expand this side. So we have 2x plus 2 times 2, 4. Now it is x we are looking for. It will have to come to the left-hand side, and then this one goes to the right-hand side. So we are going to do a swap. A swap is like your hand, like you are standing this way. You are standing this way. So this is your front view. So if you are standing this way, this is your right. This is your left. When you are facing us, this is your right, this is your left. So when I say we are doing a swap, it means that you are turning your back to us now. So when you turn your back to us now, your left will now be here and your right will now be here. But you, the human being, you have not changed. You have not changed in shape. You have not changed in shape. That is the meaning of swap. So I'm going to do some swapping here. So swap. Swap means let all the right come to the left. Let all the left come to the right. So when we swap, we'll have 2x plus 4 is equal to -15. Because I want x to be on the left-hand side. That is why I did the swap. So let's now conclude here and see the results we'll have for this one. The 4 will come and join the 15 like terms together. So we have 2x is equal to -15. This 4 is also coming, is positive, so that also become negative. We have 2x equals -19. We want x to stand alone, so we divide every side by 2 by 2. And then we do some cancellation. This 2 will cancel this 2. Therefore, x finally will also give us -19 divided by 2. Yes, Steven, go ahead and ask your question.
Hello, sir.
Yeah.
Sir, please, good morning.
Morning.
Sir, please, in terms of swapping in a question, say with that one, the signs will not change, right?
Yes, the signs will not change. It means you are taking everything. You see that when I was swapping, you are taking everything, not one thing. Take everything, everything on the right, bring it to the left. Take everything of the left, bring it to the right. It's different from what we did here. When I was bringing the 4 here, it wasn't swapping because I've left
Yes.
the 2. It was only the 4 that is moving. But assuming all of them were moving, they wouldn't move with the sign.
Thank you, sir.
Okay, so we have that was a good question. We have the first form, x to be -19/2. And we are still doing what Abraham said we should do. So let's pick this second equation. We are done with the first equation. Let's see what the second equation will also give us when we put y = 0. So this is it. This is the question. Y, this is the equation, sorry. Y equals 2x over 3 plus 19 over 3. Just as we did to the first one, wherever we see y, we put 0. So put y equals 0. Anywhere you see y, put 0 there. For this equation, we can rewrite it as 0 is equal to 2x over 3 plus 19 over 3. So I always tell you that we want the equation to be straight. We don't want it in fractional form. So because of this 3, what do? We multiply every side. So multiply both sides by 3. So I pick my 0, multiply it by 3 is equal to 3 times 2x. Let me write the x well. 2x over 3 plus 3 times 19 over 3. So we do some cancellation. This 3 will cancel this 3, this 3 will cancel this 3. 0 multiplied by 3 is 0. Is equal to 2x plus 19. I need to do some swaps because the x will always have to be on the left. So to answer Stephen again, to do the swap, take everything on the right, bring it to the left, take everything on the left, send it to the right. So if I do that, this is what I will arrive at, and then I'll get my final answer. This is what I'll have. 2x plus 19 is equal to 0. Like them together, 2x is equal to, this 19 is moving alone. And because it's moving alone, it's positive. So when it goes to the other side, it becomes negative 19. It is x I'm looking for. So I want x to stand alone. So I divide every side by the 2 here, the 2 here. This cancels this. Therefore, I have my x again to be negative 19 divided by 2, which is looking like the first one we had for the slope intercept. And we have it again for the second equation. Let's end it with the final equation here, the third equation. 3y minus 2x is equal to 19. Same principle. Wherever we see y, we put 0 to see what will happen at the end of the day. So we keep going, put y equals 0. So we put 0 here, we have 3 times 0 minus 2x is equal to 19. 0 times any number is 0, so 0 minus 2x is equal to 19. 0 minus 2x is the same as minus 2x equals 19. It is x we are looking for, so we need to get rid of this negative 2. Divide every side by negative 2, every side by negative 2. This cancels this. Therefore, x can stand alone as 19 divided by negative 2 is the same as negative 19 divided by 2. And we have the same answer again. So we had for the slope-intercept form, we had negative 19 divided by 2. And then for the point slope form, we also had negative 19 divided by 2. And for the standard form, we also had negative 19 divided by 2. So, Abraham, have you seen it now?
Yes, sir.
Yes.
Yes.
So, it means, yes, we have verified the 3 equations we have learned today. Any question?
Okay, so sir, meaning that when we put down all the equations, the values for both x and y,
Mhm,
we had negative 19 over 2,
mhm.
then y positive 19 over 3. Is that the case? So meaning that these are the values of x and y in all the various equations that we had.
Exactly so. Exactly so. These are the values of y and x in the equations that we have written. And so, what we are learning today, the rationale behind it, the rationale behind what we have learned today. Yes, Beatrice, I'll come to you. Let me finish with him. The rationale behind what we have learned today is that in business, in business, when you are solving a particular problem, there are 3 ways of solving the problem. You can use the first way, which we are calling the standard form. You can use the second way, which we call a standard form. You can use the third way, which we call a standard form. Now, what are y and x? Sometimes when we are working the math, we see it abstract, like when they are teaching you y equals this, x equals this, and you don't seem to understand all this y and x stuff. But for we in business, these equations you have seen here, there are 2 things we do in business, which I want to bring your attention to before I pick the other questions. These are the 2 things we do in business. We are using money. We are using time. We combine the 2, money and time, to give us productivity. At the end of the day, you want to produce as a businessman. So you know that the more you produce, the more money you will get. So when you want to write it in a form of equation, you can write it as money is equal to time times productivity plus seriousness. This is how a businessman is supposed to behave. Money is equal to time times productivity plus seriousness. So the money is your Y. The time is your M. The productivity is the X. The seriousness is the C. It means you need all these to be able to get good money. Now, these are the arrangements you can do with what I've written. Whenever X and Y are on the same side, it means that money and productivity are being given more attention. Money and productivity are being given more attention at the same time. And then seriousness is also at the other side. So the more serious you are, the more productivity you will make, the more money you get. That's one way of going about it. The second way is what I've explained here, that you are working with time and productivity and you are adding seriousness to it. Once you do that, you will get more money. The third way is that, okay, you need a certain money. Why? You don't know it. Because you are starting a business. You don't know whether the business will do well or not. So you are starting with an initial capital money. That is the Y1. It's a risk you are taking. You don't know the final money you get, but you are starting with an initial capital, Y1. Then you are going to use a certain time in the business. Then you are targeting a certain productivity, which you don't know. You don't know the final productivity, but you are targeting that you do well. And then you are starting with a small productivity. At the end of the day, when you combine it, are you going to get the money at the end of the day? So if you look at what we have done, look at the Y. The Y is sitting here. The Y is sitting here. The Y is sitting here. Sometimes the Y is standing alone. Sometimes it is starting with others. So whether the Y is standing alone or it is standing with the others that are time, productivity, and seriousness, at the end of the day, all you are looking for in the business is money. Whether you use the first form or the second form or the third form, at the end of the day, all you are looking for is the Y. And what we have learned today is that whether you use the first one or the second one or the third one, if you make sure that you are working with the three quantities: money, time, productivity, and then you add it to seriousness, there's no way you cannot make profit at the end of the day. And that is the perfect real life example I can give you for the formulation of the simple linear equation, that we don't use one way to get money. You can use other ways. Where the other ways, I mean, you are not looking at the money alone, but you are managing time, you are managing productivity, and then you are managing seriousness. Yes, Beatrice, I saw your hand up.
Well, sir, good morning.
Morning.
Kindly go to the previous slide for me. I observed something there and I wanted you to explain further for me.
Go ahead.
And please, the previous slide.
The previous
the
slide.
One you, please, the where you were listening. No,
Which one?
please, no.
This one.
No, sir, please, let me see. Not this one. The last
This
one we
one.
worked on before, yes, here.
Mm-hmm.
Sir, please, here.
Mm-hmm.
Sir, please, in your working, you wrote 2x it was negative 15 minus 4. And we 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 divided both side by 2. So you had negative 19. I'm kind of
Okay.
confused there. Why is it not negative 11? Because I assume
Okay.
negative 15 minus 4. So
Okay.
it should have
So let me do it this way. Let's say in maths, when you see negative, take it as you are owing somebody. If you are owing somebody 15 cedis and you go to the same person and borrow 4 cedis, what will be the total you will be owing the person?
it will be owing the person 19.
Exactly. So that's what we have done. When you see
Okay.
negative means that you are owing, you are in debt.
Okay.
Okay. So you are owing 15, you go and owe another 4. It means total you are owing 19. So that's how come we had a negative 19.
Okay.
All right.
Okay.
Then I think Stephen, I also saw your hand, Stephen.
Yes, sir.
Okay.
Okay, say please. Thank you for the class. But say, I want to ask that: is it always true that the question be given like that? With the number one and then the number two question, is it always straight like that?
So next week we'll push further. If there are other types, we'll look at them.
Say I've seen some question over here. Then isn't I'm a bit confused of that one.
Yes, so because our time is up,
Okay,
next week bring that question up and then we can look at it.
okay, sir. Okay, sir.
I don't
Thank
want
you,
us,
sir.
yeah, I don't want us to exceed our time of
Okay.
9. Any other question?
All right, sir. So for the question 1, we don't have M. So anytime you are given a question like this, you have to find M before proceeding with any other.
Yes, because if you don't find the M, it will be difficult to proceed.
Okay.
Yes, because the M, like Stephen is trying to push another question where the M will be given to you. If the
Uh-huh.
M is given to you, you don't calculate it
Okay.
again. That's why I said next week he should bring that question up, and then we can look at it.
All right.
Right? Any other question? Okay, so I think our time is up for this morning's class. God willing, we'll continue next week.
All
If you
right,
have
sir.
if you have any question, please, those who couldn't ask questions, if you have any question, please write them down so that God willing, when we meet next week, we can look at your questions one after the other, and then I can proceed with what I want to teach next week. On that note, I want to thank you for your participation, and I wish you the best of the day. The
Thank you,
class,
sir.
class officially ended.
All right. Please, let's get ready for the next class. Thank you.
All right.